Hello students, we'll just see the last topic of the fourth unit, single phase induction motor. Single phase induction motor, this is not a self-starting motor. Why? Because it has only one winding, single winding, which cannot produce a force on a rotor here. Why? Because as I said earlier, in order to produce a force, we should have at least two flux interaction here. So by having a single stator winding here, though the current is alternating current and the flux produced is alternating flux, but still it cannot rotate here. So hence a single phase induction motor is not a self-starting motor. So let us see how the motor can be started on its own way. So in order to have a self-starting here, we have to produce a revolving magnetic field here, which means that at least I should have two magnetic flux here with a phase difference here. That should have a small angle of difference here. Only then it can have a self-starting here. So therefore, in order to have two flux here, so I am connecting one more winding to the circuit, which I call it as a starting winding. So this starting winding is connected to the main winding in order to have two flux with a phase difference in it. So this two flux with a phase difference will cause a force of rotation. So this starting winding is used only to start the rotor. So once the rotor attains the rated speed, this winding is disconnected from the circuit by help of centrifugal switch. So we'll just see these operation with the help of a time. So capacitor start, capacitor run induction motor. So the word itself will tell you we have a capacitor here during the starting condition as well as during the running condition. So we have two winding, main winding and starting winding. So these winding, you just see the phasor diagram here. So these two flux will have a phase difference. A starting current and the main winding current IM will have a phase difference of pi st here. So this will cause a rotating flux here. So this rotating flux will cause the squirrel cage rotor to rotate here. And we have a centrifugal switch here which will be closed all time so that your capacitor will be connected to the system. So why we have a capacitor in the system is to have a phase difference. You all know that when we have capacitor in the circuit, the current leads the voltage by an angle. So we have we have capacitor and inductor. So therefore you'll have a phase difference within the system. So application of capacitor and induction motor, due to its high starting torque, it is used in grinder, air conditioner, compressor and conveyors. So next is the last topic, shaded pole induction motor. So in shaded pole induction motor, you have 4 poles here with a specific shape here, and the dark highlighted portion will be called as shading band. So this type of arrangement, I call it as a salient pole arrangement, that is projected pole arrangement. So we have two parts in each pole. One is shaded part, another one is unshaded part. So when we pass current through the stator winding, it will produce two flux here in each pole. That is, one is shaded flux, another one is unshaded flux. So due to the interaction between these two flux here, automatically a force is created on the squirrel cage rotor. So that is the operation of a induction motor. Remember that for an induction motor, we should have two flux here. So that is why we are connecting one more winding with in addition to the main winding in order to produce two flux, and therefore the rotor can rotate on its own here. Thank you.